because I was about to yell at you guys, and I can't yell at you guys unless YouTube gets to see you guys get yelled at. So, um,
Us, you can just
six.
pause the recording.
Yeah, I'm not gonna pause recording. So 6 more days. That's it. We're done in 6 days. So that means that we have tomorrow for Zoom and then the 2 days for our final. Your final in this class is Monday and Tuesday. It is 18 questions. Okay? And I'm doing this slowly so you guys hear me. What we are doing today is kind of like your final, only different questions, like different numbers. Okay? So if you guys are doing anything else, put it down. Even if it's in another assignment, put it down. And I want you guys to focus on this. Today's it's going to look a little bit differently. So let me pull up your period. Your review is right here, so let me grab you that link. So I am putting it in chat. Click on that link. It'll send you guys to today's assignment. So it's a review classwork period 3. Notice we haven't had notes this whole week. Today is technically the last day of us taking notes, but you, my friends, are not going to do anything. So normally when we are about to start notes, I would go, okay, now I'm going to put in my name so I don't mess with your guys' copy. I am not doing that today. I'm actually going to mess with your guys' copy. So I'm going to log in. This way, you guys, if you don't, this way, you don't necessarily have to watch Zoom. You guys will be able to see everything that I'm doing on Zoom from from ClassKick. So you just need Zoom to hear me. But everything else, you guys should be able to see this. So for instance, Ms. Gomez is going to take over all the odd problems. I will do all the even problems. And as she's writing on question number 1, you guys get to see it live. All right. So see how she's typing? We get to see as she's typing. Same thing's going to go for all the other ones. Ms. Gomez and I are going to do the top. You guys are responsible for the ones on the bottom. So we will put timers on. You guys, like, we will solve this as if we were students. We're not going to ask you guys, so what's the y-intercept or anything like that. We're explaining it as we're solving it. We're giving you guys like tips on how to solve it. And then you guys are on your own to do it down here. Do not just go, oh, well, I'm not going to do that right now. I want to do that later. Please don't do that. I need you guys to follow along and try to do your best to be in it, because then we can see what you guys are doing, so that if you guys aren't doing something right, we can stop you right there. We're sending you guys messages and drawings, like putting up stickers and stuff to let you guys know, yes, you're good. Oh my God, keep it going. Or we'll write a message saying, okay, yeah, you need to try this again. Okay? Any questions before we get started? So the question is, so what you type will be on our screen. Yes.
Yes.
Everything so look at the top question, and then once we give you guys, okay, it's now your turn, then you guys would do the bottom question. So I'm going to stop sharing so that Ms. Gomez can show you guys what I mean.
All right. So I will be working on question number 1, but anything that I do, you'll see on the screen. And anything I do is basically to help you work on question number 1 on your own. So I'll do the top part, and then after I'm done, you'll take over and work on the bottom one. And that's going to let us go into your personal final review and give you some pointers and see if you're making mistakes, if we can help you. But if you're doing great, then we'll be there to great job and everything. Okay. All right. So I'm going to start with question number 1. It says graph the function f of x equals negative 3x plus 2. When we're going to graph, you take a look at your equation and we see that this is a line because it's in y equals mx plus b form, slope-intercept. So it asks you for the y-intercept. It asks you for the slope, if this is increasing or decreasing, linear or exponential. We can't really answer these questions yet because we don't have a graph. So we don't know if it's increasing or decreasing yet, but we can look for the y-intercept and the slope. Why? Because we need those pieces of information to help us graph. So first thing to do when you're going to graph this is look at your y-intercept. That is the number at the very back here, our positive 2. So we're going to go to our y-axis here and find that positive 2 and graph it there. That's your first step. Now that we know our y-intercept, we need to look at the slope to help us plot more points. Here's our slope, the negative 3. When I have a slope, it's very helpful if I have a fraction. So I'll go ahead and write that slope as a fraction. And I'm actually just going to come over here where it says slope and write that negative 3. I could leave it as just negative 3, but again, the fraction helps. Negative 3 over 1 is my slope. I need to use that slope to put more points on there. So I have to think of the directions that slope is telling me to do. Remember, if we're at home, let's say your y-intercept, and we're trying to get to Starbucks, the slope is going to help us. So a negative 3 means we're going down 3. And the number on the bottom, the 1, tells us we're going 1 to the right. Why are we going to the right? Because it's a positive number. So let's follow the directions and get to Starbucks. Let's go down 3, 1, 2, 3, and then 1 to the right. That gets me a point there. If it helps you, you can go ahead in there and make your markings. 1, 2, 3. I went down 3, and then 1 to the right. You can make those little marks just to help you count correctly and get to the right section. But if you're okay just counting down, that's fine too. So now that we ended up at Starbucks here, you can use your slope again to plot more points if you want. Or from there, we can go back home. So let's say we were at Starbucks and we want to go back home. Then you have to go to the left 1 and then up 3. 1, 2, 3. I'll do that again. I'm at Starbucks. I went left 1 and up 3. 1, 2, 3. If I do that one more time, I'm going to get another point on the other side of the graph. So I'll go left 1 and up 3. 1, 2, 3. That lets me get a new point on the top here. So again, go backwards and you get more points on there. Once you have enough of these points, you can just go ahead and connect them. Remember, you can change the colors on these lines if you want. So we just finished graphing this equation. We started at the 2 for our y-intercept slope. Let's go ahead and answer the questions on the side. The y-intercept is equal to what? Oh, well, my y-intercept was this number in the back, 2. That wasn't too bad. Is this increasing or decreasing? Well, I can just follow that line from the left to the right, and I'm going down.
It's decreasing and it's linear.
Oh, good job. It's decreasing and it is linear. But for those of you that might have a hard time, you can go ahead and actually write the word slope. Remember that little trick? And if that word slope is coming down, then it's decreasing. And very good. It is a line, so we say linear. So this is exactly the steps you would take to answer a question like this on your test. So you guys are going to be given 3 minutes to graph your own down here. This is your equation, negative 2x plus 5. And make sure you tell us what the y-intercept is, what the slope is it increasing or decreasing? Make sure you graph it. All right, so use my example on the top to help you guys. We're going to go ahead and start your timer. We're not using songs because we want to make sure you know how much time you have left and you're not wasting time. So we'll post the timer on your screen. Don't forget, we're going into your final review, and we're helping you guys out if we see that you're stuck, or if you're doing great, we'll keep letting you know you're on the right track.
Am I doing 3 minutes?
Yes.
Right? Yeah.
Yes.
We picked nice, relaxing music.
I know, I love it. So you guys should be working on number 1 on the bottom. Good job, Adrian. That was perfect. You guys are doing great so far. Again, if you guys need help, let us know in the chat that you're stuck somewhere. Good job.
Oops. Wrong page. You guys have about 20 more seconds. No. All right. I don't think you
That
guys
was enough.
needed that much like
Oh.
help with that one. Right?
There's, yeah, the majority. There's some that are not quite finished. Oh, yeah. Oh, the bottom. Yeah. Okay, I see it now.
Yeah, I was going through there and I'm putting stuff in. Some people were, as you were talking, was, you know, they're like, I got this. It's like, peace, I'm done. All right. I'm going to switch over to page 2. So if you guys could follow along with me and go over to page 2, you guys are going to see that. No, so for these, since that music isn't really like copyrighted, I want to say that it doesn't matter, but honestly, probably like for the next song, I'll stop it just because also YouTube doesn't need to have like a bunch of like, nothing time. So I'll stop it for the next one. All right. So, oh, there's Isaac. I was wondering where Isaac was supposed to. Oh. Hey, Isaac, I'm putting in chat for you. I sent you a private message of what the link for the assignment for today. So we're doing, Ms. Gomez and I are going to do the top question and you have to do the bottom question. But as you are seeing us do the top, you should be able to do the bottom. And this is your review for your final. So these are the questions that will be on your final. Just different numbers. All right. So, just to help you guys out, I am going to zoom in a little bit so that you guys can see everything. Distributing. I see a lot of people be able to do this part. This part is easy for them. 2 times x gives me a 2x. The part that I'm having still a lot of people make a mistake is on the next one. They'll draw the arrow, and instead of putting in the answer, they'll put in a plus 2. Because they're not paying attention to this -1. They're only paying attention to the plus 2. Or they'll just still put in that -1 and they won't even multiply anything at all. So please, please, please be careful and make sure you're multiplying it by everything. 2 times x gives me a 2x. Why? Because there's technically a 1 right there. Okay? So 2 times x gives me 2x. 2 times a -1 gives me a -2. And then everything else comes down, which I'm not seeing any of you guys really have a problem with that. The next problem that I see from a lot of you guys is you'll see, okay, I have this 2x here. I have this -x here. And for some reason, again, this is a don't do this. Again, I'll do that in red. I'll see this. And then I'll see people like add 2x or subtract 2x from both sides. Please don't do that. That is not the right way of solving this. That's only done, upside down T is only done if you're moving one thing to the other side. So what we're trying to do, and I'll put it over here on the corner so that you guys don't make that mistake. What we're trying to do is we're adding like terms. So combine like terms. That's not a T. Hello, stupid. I called myself stupid, YouTube land. Not you guys. 2 minus 1. Again, there is this invisible 1. So what am I doing? I'm doing 2x minus 1x. So 2 minus 1 gives me a 1x. So I'm going to have 1x right here. Bring down my -2 equals 16. From here, again, we want this x by itself. So now we do that upside down T. And I'm going to do add 2 to both sides. And I get 1x equals 16 plus 2 is 18. And I'm going to do this in, so a couple of things. Remember, I could like what I've been seeing is 2x minus 2 minus x equals 16. And I'll draw this in red because I don't want you guys to do this. And you guys would subtract 2x from both sides. And subtract 2x from both sides. Or something like that. Again, let me do this in red. Do not do that. All right? An extra example, if we had something in the front, like let's say we had a 3x equals 18. Again, this would I have in orange as an example. I would then have to divide both of these by 3 and then get x equals 6. So what's in orange is an example. But what's our final answer? Our final answer is 18. Please, please, please do not forget to put your final answer. All right, so any questions on this one? Why we only do that when we want to move y? There's no y in this one. So you must be thinking of when we're doing substitution.
Oh, yeah.
Yeah, this looks really similar to a substitution problem, which is what we've been doing. This is, pretend that we had already substituted and you're just trying to find what x is, and that's it. Okay? So that is an example. All right. How many minutes is it for this one?
5.
5.
So think about it. You just did graphing by itself. You just did solving by itself. We're going to combine those two skills for systems of equations, which is why you're doing this first and the second one.
Yeah, and I'm pausing.
So we're going to go ahead and move on to slide number 3. So if you were still working on slide number 2, you can go back to it. As soon as we're done with this one, you don't want to miss what we're working on the next slides, because that, again, this is going to help you work through that slide on your own when it's your turn. But some of these you're going to finish a lot faster, and you can go back to those other questions. Okay, so slide 3, we're moving on. This question is asking you to solve the system of equations. So now we're at systems. This is what we were talking about this past week. You want to show your method or explain your reasoning. Graphs are provided if you need them. Remember, we had 2 options. We can either graph or we can use substitution. Oops, sorry. You can graph them or use substitution. But remember, we talked about the little pointers that can help you decide what method to use. That's to look at your equations. So our first equation here has y equals negative 3x plus 2. That's in slope-intercept form, or meaning y equals mx plus b. The second equation also has y equals mx plus b, but x minus 2. So both of these have our y solved, and that means we can solve this system by graphing them. So yes, you can do substitution, and I've seen students use substitution here, and if you like that method, you can use that method. Remember, we said you have the choice. But since we're practicing graphing, and some of you do need the practice, we're going to take a look at how to graph the first equation here. Remember, start at the number at the very back here, plus 2. You have to put that plus 2 on the y-axis. You have to put a point. If you're not going in there and actually putting points, your lines are not going to be very accurate. And some of you were having that problem on question number 1. Actually go in here and draw some points. So that's our positive 2. Now you need to use the slope. Well, let's look at the slope. It's a negative 3. It helps if I write that negative 3 as a fraction. So I'll put a 1 under it. Now I have negative 3 over 1. Remember, the top number is your rise. So a negative tells me I'm going down 3. The bottom number is our run, which tells me I'm going to run 1 to the left. I mean, 1 to the right. So go to the number 2, the y-intercept here. Think about this as your home. The slope gives us directions to get to Starbucks. This slope is telling me I have to go down 3 first. 1, 2, 3, and 1 to the right. 1 to the right gets me a point there. Again, you're going from your home on the +2 to Starbucks. 1, 2, 3, 1 to the right. If I repeat that, I can get a longer line on here. So I'll go down 1, 2, 3, and 1 to the right. These markings that you see me doing here just help me get my line as accurate as possible. So if I have enough points there, I can go ahead and graph this line. Oops, I should connect them. There we go. That's my first line there. And I'm going to have to repeat that exact same process, but with the second equation. So now I'll go and look at the second equation, y equals x minus 2. And again, I start at the y-intercept. In this case, it's -2. So I go to the y-axis, put my point on that -2. Let me use a different color for this one. Here's my -2. All right, now that I plotted my y-intercept, we need to look at the slope. Here's the slope, but in this case, we just have a single x. Technically, there is a 1 in front of it. So my slope is just 1. If we write it as a fraction, it'll help us get a correct point on here. So let's go and write a 1 underneath it. Remember, the slope is your direction to get to Starbucks, but in this case, we're going to in and out. So let's say I have 1 on the top. If it's positive, it's telling me to go up 1. If I have a 1 positive underneath, it's telling me to run 1 to the right. So if I do that, I go back to your house, to my home here, and I need to go up 1 and 1 to the right. There's my point. Some of you might notice, oh, it's already touching or crossing that line. Yes, it is, but if you want, you can go in here and put some more points. I'll go up 1, over 1 again, up 1, over 1 again. Since we have enough points here and we see where these lines are crossing, I can go ahead and just connect these. I can get rid of my slope marks here. And now I'm interested in a solution, which means we need to find the point where these two lines cross. Here's the point where these two lines cross. How do I write that point? Remember, you need parentheses. The first number in the front has to be our x, and our second number in the back has to be our y. This is your x-axis, this is your y-axis. So the number on the line here, that's x. The up and down one is y. So if I want to get to that point, I need to go to +1. And then I have to go down 1, which puts me at -1. So this would be the solution to this system of equations. You need to graph both lines. And as soon as you're done graphing them, you need to find if these two lines intersect. Will they always intersect? Not always, but in this case they did. So find that solution. Okay, use my example on the top to help you graph the one on the bottom and find the solution. We're going to give you guys, we said 5 minutes for this one. We're going to give you guys 5 minutes to graph both of them and see where they intersect if they do. Okay.
5 minutes. Nice job. A lot of you guys are like monsters, man.
Oh, I see someone using substitution. Ooh.
You're getting too fancy on us. Some of you guys are just messing around. Other of you guys, oh my god, fed.
Remember, we need to see your work, boys and girls. If this were the actual final, we need to see your work to get your full points.
Yeah, if you just had like the correct answer, that's cool. You know, instead of getting 4 points, because every single question is going to be worth 4 points, guys. And if you just have the answer, you might just get 1 out of 4. So you need to make sure that you guys are showing all of that work. No, that's not what I said. All right. I want to say for the most part, I saw everyone doing it right, which I totally forgot to pause it that time, but whatever. God, Jessica, where were you?
I private messaged you and you didn't see it.
Of course I saw it. Wait, no, I have no excuse for that one. Every single time I start sharing the screen, the chat goes away, and then like I don't. Stupid. God. All right. So for the most part, I'm gonna say all of you guys got this. Your solution should have been 1, -2. Yes.
Yes. Yes.
So if you guys didn't get 1, -2, check your slopes, because I want to say some of you guys thought it was like no solution, or you magically got the solution, but you had no graph and no work. That doesn't know. Again, guys, like if you're gonna cheat, cheat smarter. All right. All right, so this one's mine. So I can't zoom out no more. Oh, I don't know. Either like pinch it or use these thingies over here in the corner. How did I get paint? I don't even have paint. You guys don't have children. All of a sudden, like you have like random like marks all over your like body. Or it's from me using like some of my markers and stuff. Or I don't know. I don't know anymore. I don't know what's going on. All right. So there is a trick to this question. However, I am not going to say anything about the trick until the very end. If you guys got, like, were paying attention to me or to Ms. Gomez, I don't remember who's the one that actually taught that lesson. But if you guys remember, we talked about like looking at our equations and maybe being able to do less work versus more work. And that was Ms. Gomez teaching that one. And then I jumped in going, you don't want to have to do more work, so pay attention to what she's saying. So, yeah. Okay, I'm not going to get distracted. I'm sorry. Someone's already yelling at me. All right, so we're going to do this top equation first. I see that I have my y-intercept right here, so that's 3. So count 1, 2, 3, plot my point right there. Most of you guys are able to do that part. It's the slope that drives you guys nuts. So I have a 2/3. What does that mean? That means I'm going to go up 2, and I'm going to go 3 to the right. Okay, so from this point right here, I'm going to go up 1, 2, and if you guys need to zoom in, then zoom in. Again, 1, 2, 1, 2, 3. That's going to be my point right there. Now, if you need those like little like squiggly marks, that's fine. No big deal for you guys to do that. 1, 2, 1, 2, 3. Plot my point right there. However, I normally like to have 3 points. Sometimes I can get 3 points. Sometimes the graph doesn't let me because it's so small or it's like in the corner somewhere. That's fine. But I can go backwards. So I'm going to write the word or, and I can do the opposite of what I see. The opposite of a +2 is a -2. The opposite of a +3 is a -3. So what does that mean? Since it's negative now, I'm going to go down. And since that one's negative, I'm going to go to the left. So from 3, again, I'm going to go down to 1, 2, and to the left 3. 1, 2, 3. Plot my point right there. And then connect my dots. And I'm going to make that purple so that it matches. All right. So far, so good. Next one I'm going to do, let's do orange. I like orange. No, I don't, but it's okay. So -4, I'm going to go, again, I'm going to pretend that this line doesn't even exist. And I'm just going to focus on this new line right here. So 1, 2, 3, 4, plot my point right there. And then I'm going to look at my slope. Stop it. I'm getting used to writing with a mouse, and it sometimes moves, and I don't know why. I, again, have 2 over 3. So what does that mean? I'm going to go up, and I'm going to go to the right. So I'm going to go up 2, 1, 2, 1, 2, 3, plot my point right there. I can't go any more on this side, so again, I'm going to do my OR, and I'm going to do a -2 and a -3. That means down, that means left. So 1, okay, so see, this is a perfect example of not being able to do the bottom part. Totally fine. That just means that, you know, I have to hope that it's 100% right. But here we go. How many solution is this? It's no solution. No, not me solution. No solution. Now, if you guys had been paying attention before, you guys could have seen right here, okay, I have the same slope for both of these, but my y-intercepts are different. So if you remember the, like, I think, I don't remember how many, it was last week, I think, that we wrote about this. Same slope, different y-intercept equals no solution. However, same slope, same y-intercept equals infinitely many. I feel like I spelled that wrong. Did I spell that wrong? Is it T-E? I always spell infinitely wrong. Whatever. I don't care.
That's correct.
That's correct? Okay.
I always
So
think of it as finite in the middle.
Oh.
Infinitely.
So I'm going to make this orange, and then the bottom one, I'm going to make it like blue. Blue sounds good. All right. So if the slopes are the same, but the y-intercepts are different, then guess what? All of this work that I just did, I don't get to do. I get to just go straight to the solution and be like, oh, it's no solution. Ha ha, suckers, I don't have to do anything. Or if I saw that they were the same y-intercept, same slope, same y-intercept, meaning both of them were the same, then I would have infinitely many. Normally, you won't see them like this. You would have seen them, oh geez. You would have seen it like, what would that be? It would be -2x plus 3y equals -12. Yes, it would have looked like that. That would have been the same. Both of these are equal to each other. So this would have turned into that if we solved for y. Okay, so I'm gonna give you another 5 minutes because last time everyone needed the extra 5 minutes. So can they look like that with substitution? So if it was substitution, you would have seen it like this. You would have seen the negative, like this part right here, and you would have seen this part right here. And when you plug it in to each other, For instance, like I would get the negative 2x plus 3, and then I would put in the 2 over 3x plus 3 equals negative 12. I would have done that. I mean, obviously, you're not going to use substitution when there's a fraction one, but you would have put it inside, and then eventually you would have like 3 equals 4. Let's just say it's not, but it's 3 equals 4. Is that true? No. So that's a no solution because they're going to be different on both sides. So if you saw no solution, you would have 3 equals 4 for substitution. So let me actually put it right here. So for substitution, no solution, example, 3 equals 4. Infinitely many, example, 5 equals 5. Does that help? But I am gonna, and then resume recording, and then it's on you.
All right. Mine's lagging now. Okay, here we go. All right, so we're moving on to slide 5. So make sure you guys are moving along to slide 5 with us. Again, all of these are similar, but you see something new or something a little different in each of these problems, okay? So 5 is slightly different from what we've been doing in the other ones, but it's still a system of equations. But you're gonna see how we can solve through, work through this one. So this question is asking you, how many solutions will there be to this system of linear equations? Well, a system means we have 2 equations. You want to look at the first equation. Shows us y equals negative x plus 3. That one already has y by itself, and we can graph it if we wanted to. So that's one option. When we look at the second equation, 3x plus 3y equals 9. This one is not in slope-intercept form, so it could be a little harder to graph it unless we make some changes to this equation. So if you remember our little friends from the other day, they would probably tell you to use substitution here. So we'll go ahead and practice substitution. And I know a lot of you guys in this period are fans of substitution. So let's go ahead and do that. When I look at this first equation, oops, that's not the pencil. There we go. When I look at the first equation, y is already by itself. So I can take what is on the other side of the equal sign. I can take that and remember, go wee right into the y, wherever we see our y. Here's our y. I'm going to replace that with negative x plus 3. So I'll go over here and I will retype the equation just like we did with our activity. If I retype it, the 3x stays the same. That looks really faded. Let me use, there we go. The 3x will stay the same, plus the 3 that was in front of the y will stay there. But now I should use parentheses to put in my new expression, which is negative x plus 3. Close that parentheses, and then that should equal 9 because the second equation still has that equal to 9. All right, so again, we just substituted, we just plugged it right in. So now what we have to do is solve for x. So we're going to solve for x by working through this equation. Well, the first piece here, 3x, needs to stay by itself since I can't do anything there yet. But what I notice is this number 3 in front of the parentheses needs to be multiplied by everything inside of the parentheses. So what I should do is do 3 times that -1 here. And that gives me -3x. Now that I did 3 times that -1, why was it -1? Because there's a -1, sorry, there's a 1 in front of our x. Now we want to do 3 times 3. Since it's still inside of our parentheses, we have to do that. I realized that this isn't a very good color for this, so there we go. 3 times 3. 3 times 3, that's just a +9. So I should write that +9 here. And just bring down that =9 since I'm not doing anything to it. All right, so we get a pretty interesting step here. Your next step is to combine like terms. So if we have any x's, we can combine with each other. This 3x minus 3x should be 0. So think about it. If you have 3 of the x's and you're taking 3 of them away, that is just 0. There's nothing left. Some of you get confused and you think it's 0x and that's just x. No, if you have 0 x's, that is just 0. So we need to leave that 0 there. Bring down that +9 and bring down that =9. So on the left side, we have 0 plus 9 is just 9. And on the right side, we have it equals 9. So we get a pretty interesting answer here. Our x's went away. There's no more x. There's no more y. But here we get a true statement. 9 is equal to 9. That is true. Where's my pencil? There we go. So because 9 equals to 9 is true, this type of solution is going to be an infinitely many solutions. Why did that go black? So a true statement is an infinitely many solutions. So we say our answer here is D. But again, we got that from seeing that 3x minus 3x canceled out. It's gone. It gives us 0, which means we just have 0 plus 9. And the statement 9 equals 9 is true. So this is a different example of when we get infinitely many solutions. So it's going to be your guys' turn. We're going to give you guys 5 minutes. Is this still 5 minutes? Oh, we cut it down to 3 minutes. Did you want to do 3 or 5?
3 because of time.
Okay.
How did we get so far with first period?
They were moving a little faster than a lot of the other periods. Interestingly enough, yeah.
All right, so